Okay, it'll probably work. Um, so, so going to just start building a GUI program a few steps at a time, just like what's going to be in the lectures, but I'll really just focus on putting it in perspective for that mini project. So as you know, I say as you know, has anyone looked at the mini project? Yeah, you have.
I didn't realize it was up yet.
Okay. So then let's just quickly go through the project description. So the idea here is to make an editor that can edit some graphics, and so there'll be three kinds of graphics. You can have, we'll start it at any rate with rectangles, with text, and with images, and so you can add those to a canvas or to a scene as it's called here, and then they all show up. And so it doesn't work with CodeCheck because CodeCheck doesn't know how to deal with GUI programs. So you'll just turn it in, and so it turns in four different phases. And I'll make it so that I'll just publish everyone's results at the end of whenever the turn-in was due, and then you can harvest whatever you like from everyone. Because I don't want people to fall behind. So because otherwise, if everyone does it in the last minute, then it's no fun, and you're not going to learn anything from it. So the idea is to just over time get better at this GUI programming, one step at a time.
What are you using for the GUI?
What's that?
What are you using for the GUI?
Oh, Swing.
OpenGL or something?
No, good old Swing. I mean, it's a Java course, and so whether you're ever going to be using Swing for anything in your life is pretty debatable, because it's old-fashioned. But Swing is actually pretty well designed, and so you can learn something from the design that's useful for other GUI toolkits. Like there's a successor toolkit called JavaFX that you may have heard about, and so JavaFX is good for one thing, is if you have like a lot of animation and the kind of thing that people used to do with Flash. For everything else, it's kind of a step in the wrong direction, and Swing is actually better. But learning Swing will also help you if you have to write an Android app. And I was actually thinking, should one get students directly into Android? And maybe we'll do that at one point, but we're not quite ready yet. There's a significant learning curve, where Swing is really pretty easy. So in fact, I will just walk you through how to write a basic Swing app that looks suspiciously like phase one of the homework assignment, and we'll just see how to do it. So whenever you want to have an app, you first need to put up a frame. So let me make a new project here. This is the mini project. So I'll call it a scene frame. I think that's, double check that that's what we're supposed to call it. I didn't say. Okay, but I'll call it a scene frame anyway, and it extends JFrame. So JFrame is the class to show what's called a frame window. A frame window is a window that has a title bar and that just shows up in the ambient windowing system. So it's imported from javax.swing. JavaX instead of Java because a long time ago people thought, oh, this was more like an extended thing, and nothing ever came out of that distinction between Java and JavaX, but there it is. So we're extending JFrame, and now we need to just say what makes a scene frame different from a JFrame. Right now, not much, but let's spell it out in the constructor. And so there's a few things that you have to do. You have to set the size. For now, at least, we have to do that. So we'll just make it 400 by 400. You can set the title. You can set anything you want. we have to do something. We have to set the what's called the default close operation. Oh. To a constant that's called exit on close. If you don't do that, then if you close the frame, it doesn't terminate the program, which looks funny. And that's pretty much all we're going to be doing here. So by doing this, we don't yet have a running program. For that, I make a separate class that I'll call scene viewer. And that's a class that'll have a public static void main. Now, better to give it the right one, otherwise it won't start. Now, for some weird reasons, you have to do something technical now. You can't. There's certain things that you can't do on the regular thread. You have to do them on the what's called the event dispatch thread. I'll show you first what it is, and then I'll explain it. So we're going to have to do the frame construction and showing the frame on this event dispatch thread. Technically speaking, I believe you can construct it without it, but it doesn't much matter. So we're going to make ourselves a frame, scene frame, scene frame, a new scene frame, and then we're going to show it. To show it, you have to call set visible true. And that's all. So when we run this, then over here you see a 400 by 400 frame, and it has nothing in it. So now let's put something in there. So you can't draw directly on a frame. In Swing, you have to draw on what's called a component. So I'm going to be making a component class. Oh, what am I doing? Not paying any attention. So we'll call it a scene component. Now a scene component, so any component class has to extend JComponent. Import this. And a component is a component by, I guess there's two kinds of components. There's the ones that hold GUI elements like buttons and sliders and stuff, and then there's the ones where you do your custom drawing. So right now we want to do some drawing in here, so I have to override the paint component method. So paint component gets a thing called graphics, and you can think of graphics as like being the moral equivalent of like an output file or something. Anything that you do on the graphics shows up on this inside the component. So, for example, I could say g dot, and then there's a whole bunch of methods here that I can use, and I'll use one, and then I'll do it differently so you can see the differences. So there's a method called drawRect, and I'll draw a rectangle from that starts at 10, 10 and has width and height 100, 200, just to do something. So now when I run my program again, nothing happens because I didn't put this component anyway. So I should be putting that component into the right spot, and so let me do that. So in the scene viewer, in the scene frame, I now have to add the component to it. So that's a scene component. And now the frame contains a scene component. So let's see what now happens. And now you can see here, I have my component, and inside it, you see that rectangle. So it's a little bit roundabout, but once you have the basic framework, now it's easy enough to add more things. Like if I now also wanted to have some text in here, then let me kill a few of these. Then I have to go back to the component and now add some other instructions. So there's, for example, a g.drawString. And so I need to give it a string, hello, and say I want it to show up on 100, 100. Maybe on 50, 100. And now you see the string hello appearing. Now that's all good and well, except what we want to do is something that's a little bit more object-oriented. Instead of calling a bunch of methods inside here, I want to be able to have different objects that represent the different kinds of things. So I want to have this rect shape and text shape and image shape, and that way I will make myself a list of shapes, and I'll be able to read them in from some file and so on. So let's just follow this here. And I'll start with I might as well start with a rect shape. So we're supposed to make a superclass or a super interface shape with a method draw, with some abstract method. So let me do that. And since I know I don't yet have any reason to choose a class, I'm going to make it an interface. If later on it turns out that we want to put data in there, then we can always change our mind. But right now, we'll just say shape as an interface. And so we're told to put this draw method in here. Okay. Now, there's this graphics 2D thing that I'll get to a little bit later. Right now, we're just going to go with it and say that's what we want. If you recall, in the scene component, we had a graphics instead of a graphics 2D, and that's some idiocy because the library is quite old. So now let's add I'll start with the text shape because I think that's the easiest, at least to get going. So we have a new class. It's a text shape. I know text shape sounds funny. And so it'll implement shape. And now that means that we need to implement the draw method. And now a text shape object now needs to remember where the text is. So we need to have some instance fields for that. And let's see, it says here it's constructed. It says here with the font name and size. I'm skipping that here for right now and leaving that to you. The text string and the x and y coordinates of the top left corner. So let me do that. So I have a private. Oh no, it's an int x, private int y, private string text. Now let's get a constructor. Generate constructor using fields. So in Eclipse, this is a useful shortcut. You can make a constructor that automatically assigns to all of the fields. So I'm going to do that here. Now to draw one of these things, that's where I now use the old-fashioned draw string method. And so the string is, of course, the text, and it gets drawn in x and y. So now let me rewrite my program here to use some of these shapes. So in the scene component, I'm not going to do this drawing anymore. I'll factor this out because I'll need it later. But instead, I'm going to say, what's a scene component? A scene is a bunch of these shapes. So I'm going to just store them in here. Okay, I need to import array list. I'll need a method to add a shape to it. And then in the paint component, I'm not going to draw all the shapes that there are. So for shape S shapes, S.draw, each of them knows how to draw itself. Now there's this technicality with the graphics 2D. What you have to do is what you're getting is actually a graphics 2D, and you'll see later why I need it. For right now, I'm just going to cast it. So the graphics thing that I get is always a graphics 2D. They really should have changed the paint component to take a graphics 2D. But 15 years ago, no, more than that, right, 18 years ago, they said, gosh, we have 2 years of code where that would be messed up if we changed that. And now 18 years later, we still have to do this. Yeah, people are always surprisingly short-sighted when it comes to this. So a scene component really, all it does is it paints all of its shapes. And now the responsibility for painting is properly with each shape. And that's a better design. That way, each shape knows how to paint itself and will take advantage of polymorphism in just a minute. Now, right now, we only have one kind of shape, so let's draw that. So in somewhere, we need to have a way of making these shapes. So I'll put that in the frame. And I guess right now, yeah, that's now a design decision. Well, we're going to do it. So let me think this through. I'll add a shape, an add method here as well. Oh, now I need to expose my component. So over here where it said add new scene component, I'm going to have to say add comp. Here. So now I can do all my work in my viewer class. is here. In fact, I can do that outside this weird code. So now I can make a text. I see. I need to make the frame here. I believe this is safe. New text component. No, not new text shape. So how do we make a text shape? We give the x and y in the text, or was the other? I think so. Let's try it. 100, 100, hello. Seems to work. Now we'll put a second one in here. And let's see what happens. And so now you can see this is a text component that shows up here. This is a text component that shows up here. And of course, now by the design, you can put in as many components as you like. They all get automatically rendered. So it's a little bit roundabout. So we're adding it to the frame. The frame adds it to the component. The component adds it to the array list of shapes. And then the paint component method will paint them all. And it'll then call the draw method of each of those components. Like here you have the draw method for this one here. Now later we're going to have to gussy it up so that it takes advantage of fonts as well. Right now there's no font treatment yet. But that'll just mean to change the drawing, to first change the font and then do the draw. Let's do another shape. We'll do the rect shape. So it's a shape. So we need to override draw. Okay. Now a rectangle has what? It tells us here. So it's constructed with the RGB color values for the shape color, true if the shape is filled, false if it's not filled, followed by x, y, width, and height. So let's see. So that means we have in a shape we have a whole bunch of different things. So we have the red, green, and blue. We have a Boolean whether or not the shape is filled. We have an x, y, width, and height. And I guess they should all be private. Be nice if that had been the default. So now I'm going to again do the constructor from field thing here. That gets me my constructor. Notice, by the way, this bizarre and useless call to super. There is no superclass, right? The superclass is object. We're not passing anything into object, so it's not really necessary. I have no idea why Eclipse does that, but it does. So that's actually a little bit ugly. I don't really want RG and B as separate values. I just want to have a color object of that. So I'm going to change this here to say color. And then over here, I'm going to say this dot color is new color. Of our table. Now I need to import color. Now we have a perfectly good constructor for this thing. Now how do we draw it? I have to first set the color, and you do that by calling set paint. So now whatever is going to happen next happens in that color. And now I make myself a rectangle. Of xy width height. I guess I could have done that in the constructor. Yeah, I think that would be better. Let me do that in the constructor. It's more object oriented. Okay. So now I have the rectangle. I can draw it whenever I want. So I just say G2 dot draw of R. Except I want to either fill or draw it. So if filled is true, then I want to call G2 dot fill of R. And otherwise, I call G2 dot draw. So that's a rectangular shape. You can see here again in the constructor, I'm storing the color, I'm storing the rectangle, and then in the draw method, I set the color and I either fill or draw the shape, and that's how it'll appear. So let's try that out by adding a couple of rectangular shapes. That went on in the viewer here, and I'll just add some to see how it goes. So add. Now let's see. So we want a new rect shape. And what did we have? We have the color, so let's do one in red. We have whether it's filled or not. Let's have it not filled. And now the position, so I'll just put one. And then we'll do one in blue that is filled, or it was green, right? Whatever. Yeah, I guess we have to put it somewhere else. And now when we run the program, then you'll see one of the shapes is here, one of the shapes is here. Here are the two text shapes. And you see that that initial pane with the architecture is now paying off nicely. Now I can just add whatever shapes I want. So let's see where we are in terms of the assignment. So we've done the rect shape, and that one looks pretty much done. The text shape, we're not yet done with the font, and the image shape, I haven't done anything about it. We have the scene component that has an array list of shape, paint component calls draw on all of them, so that's done. Now it goes on and say, your main method should read a file with shapes and draw all of them. The file has a specific format. All right, well, let's make a file like that. New file. Here it is. There must be a typo because there's no point size here. Okay, we'll put the point size in here. Okay, so now we have to read such a file. This has nothing to do with GUI programming, really. And now the question is, where do we want to put it? So right now I've put all of this stuff here into the scene viewer, and I guess we can do that. The other thing that we could do is we could put a method into the scene frame that's a little bit closer to read a file. So let me do that. Now it's likely going to throw an IO exception, and so what? So here's how you make a scanner that reads in. We read a line at a time, so the scanner is just perfect. Yeah, just import it. Okay, so now I have this line here, and it's going to be one of these lines here. So what should I do next? Exactly. Split, right? So I split on the commas, and then that way I'll be able to process it. So, okay. Fields, split a comma, or if you want to be more permissive, you allow some white space around here. So then we would split by this regular expression. And if one were to be really ambitious at later on, what if someone wanted to put a comma in a text string, then this wouldn't work, but then you could use the CSV thing that we did like 2 months ago or something, when we first learned about packages. But this will get us going for right now. So now we have these fields. Right now, not going to do any error handling. It's not a requirement because this part is about GUI programming. So the field could be one of these three things. It could be a rect shape, a text shape, or an image shape. So field 0 equals rect shape. Then we'll do something text shape.
But can you use reflection?
I could, and later on I'm going to invite you to do that. One could have done it at this level, and I was thinking of whether I want you to do that, but I decided against it for some reason. But yeah, so you will see in part 2. Oh, I know why. Because I said, gosh, then there's a bunch of hard reflection work right in the first in the first deliverable. So I wanted to defer that for a little bit later. So it's actually here in part 3 where there's a general shape, and it'll use reflection on this thing here. So, but yeah, feel free absolutely to use reflection right here. It's it'll look much more impressive, and it'll work the same way. Right now, we'll just do it in a mundane way. So, if it's a rect shape, then I need to add a new rect shape, and now the rest is just boring. Right now it has 7 or 8 arguments, and so I have to convert some of them to integers. So if we look at this, so I have these 3 here. Oh, then I have a Boolean. Is there a Boolean parse Boolean? I have no idea. I'm just going to manufacture my Boolean like that. If the field is true, then it's true, and if not, then it's false. There's got to be a more elegant way. Oh, now I have more text fields, I think. More integers. Yeah. Okay. So now in my scene viewer, I no longer do this, but I call scene frame dot read drawing on the text. Eventually you can make it so that it reads it from args, but right now we'll just do that. This threatens to throw an exception. And we'll just throw it right out. I mean, you could later on catch it and do a better job with that, but right now this is good enough. So now when we run this, we get an exception. And so that's because it couldn't find the darn file. Now this is a perennial problem with Java, that when you do this in the GUI, that the file apparently does not get copied to the right place. So let's just put in the absolute path name here. Okay, where the heck is the file? Here it is. Here's the rectangle in red. Where's the text? Wasn't it supposed to also have a text and an image? Yeah, we didn't put that in yet, right? So then, now here it's the same thing, and now you're going to have to see what the heck was the text. It had, where was it here? It had a string, a number, another string, and these three numbers. Fields 1. That was the font, which so far actually we haven't really done, so I'm going to comment it out. Then we have a string, so that's fields 3. That's the string we actually want to show. And then we have the x and y. Was that all? 1, 2, 3. Okay, this looks wrong. Oh, I see. Yes, this is in fact wrong. I need to fix that in the description. So we want the top left corner, and we want the point size here. I somehow had it messed up in the description. Okay, what do we get? Constructor string int is undefined. Text shape. Oh, because you have it as int string. I'm going to change it around. Okay. And now you can see here the string here. There's an unhappiness here. It's in red. Why is it in red? The color never got changed back. So the first shape set it to red, and this is a little dumb the way that these graphics contexts work. They're stateful. So with colors and fonts, they remember whatever the last color or font was that one added to it. So what I should be doing is there's one of two things I can do. Either in the one that draws the shape, I could change it back to the original, or I could, before drawing the text, I could force it to black. And it doesn't much matter which of the two ways you do it. Trying to think what's the most elegant way just to show off. Okay, yeah, so the elegant way is that here this thing gets a graphics context if one makes it so that this one doesn't remember anything, and that would be as follows. It's not the way it's in the book though, but it's a good technique. So let me show you this. So there is a way, and I can't remember what, but it'll come back to me when I look at the Java doc. There's a way of cloning the graphics context, so to speak. It's not quite a clone. Oh, it's not coming to me. Oh, you know what? I think I can just construct it. Create. No, here it is. Create. So I say create. Oh, that didn't work. Oh, well, so much. Okay, then I'll do it the boring way. I thought this would kind of work. So then over here, sorry, the text frame, I'll just force it to black. Oh, because it didn't import color. Okay, now it's black. So one thing that I didn't yet deal with was the font. So let's do the basic thing of the font. It's actually quite easy. So here we would like to set the font name and the font size. And just like what we've done before, is instead of stashing them away, we stash away the high-level object, the font object, and we construct it in here. And now you can construct a font with a font name, and I can never remember whether then it's the style. I guess I need to first import it. I know that. So there's a font string int, and unfortunately one of these ints is the style, and the other is the point size. They're both integers. Bad design. And now Eclipse doesn't tell me which it is. Well, let's try it out. I think this is the right order. Oh, it should be in it. Here. So now before the drawing, I have to set the font to the font. Okay, where do we have an error? Oh, and now here I have to uncomment these. Okay, oh, because I had a typo here. And it worked. Right here you can see incredibly ugly. The font here. Now, it didn't actually quite work correctly, and let me show you that. So the way that that was described in the spec was to say that you specify the XY coordinate, where was it, of the top left corner of the font shape, or the text shape. Here you construct it with blah 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 text string, and the X and Y coordinates of the top left corner. Let's see whether that's actually true by putting a rectangle at the exact same location. So in drawing one.text, I'm going to add another shape. I'm going to say I want to have a rect shape, and I'll make it black. I don't want it filled, and I want it at 200, 200, and then it doesn't matter. I just want to see whether the corner is right. With the rect shape, the corners are right. It really does draw the top left corner. And now you can see this is not working. This is the top left corner here of the rectangle at 200, 200. And for whatever evil reason, it does not put the string so that the top left corner is there, but it appears to be the bottom left corner. And so what we would have to do is we would have to draw the string, we would have to somehow figure out how to move this thing down. Now it's actually not quite the bottom left corner. And let me make another slight change here. Let me change it to goodbye world. So you notice that the y here does seem to kind of go down here. So so the 200, 200 where it draws the string, what is it? So how would you describe? The vertical one is clearly the leftmost part of the string. But what is the horizontal position?
It's just like the bottom corner of box around the first character.
So it's not the first character. So you've been looking at fonts and characters all your life, but I guess until one works with these at this detail, it's not something people think about. So when one sets a line of type, you want there's what's called a baseline, and the baseline is where all the kind of normal letters end up, like the O and the D. But there's some letters that have these descenders that go below the baseline, like a lowercase g or a lowercase y. They have this thing that goes below, and it would look pretty weird if the y here, if you had it moved up, so to speak. We're expecting that some of these things, they're called the descenders, that they go below the baseline. So every font knows where its baseline is compared to the topmost line, and also where the line that all the descenders end are compared to the baseline. And so there's something in the book that tells you how to do that, and so I want you to figure that out and make the correct adjustment here. And it's an important thing whenever you work with fonts. You just have to do that. Now, you may or may not ever have to do that, but it's surprising how often this it comes up. Also notice that that the sizes of these things can change. The W, for example, is quite a bit wider than an O, so it's not always easy to estimate how wide a font is. We don't care about that here because we're only supposed to do the top left positioning. But if you wanted to put the thing in a box, there's some sample code in the book that does that. Then you need to know exactly how to measure a string. All right, so that's that part. Now about those images, that's the other thing that we didn't do. It's actually pretty easy to draw an image. There's a call to draw image, and it's also described in the book. And so you can follow the same logic to add that up. So that's what I wanted to show here. Any questions about the structure of this thing? Anything that you want to see again or want me to highlight one more